Assalamu alaikum and good day to all of you, my dear students. In this tutorial, we will only apply on operations of radicals. Reminder: to find the radical of a positive real number, we express radicand in form of an even exponent, if possible, and divide the power by the index of the radical. In our case, in grade 8, it would be 2. Calculate. I need you, my dear students, now to stop the video, grab a pen and a pencil and try to solve these questions. Okay, let's find now radical 16. Remember, we always have to write the radicand in form of even power if possible. If not, we will look for another way. Now, is 16, how can we write 16 in the form of an even power? Yes, it's radical 4 squared, which is equal, divide the power, the even power by the index, we'll get 4. Easy. So square root of 16 or radical 16 is 4. Now similarly for radical 400, we'll try to write radical 400 in the form of even power. Can you write 400 in the form of an even power? Yes, it's 20 squared. Again, divide the power by the index to get 20. So we say 20 is the radical or square root of radical 400. Now notice here that the radicand is in form of power but not even power. In this case, we said before in video 1 that we can write this radicand in form of product of two powered numbers, one of even power and the second of power 1. Okay, now radical 5 power 11 can be written in form 5 exponent 10 times 5 exponent 1. Now divide the power by the even index to get 5 exponent 5 radical 5. Easy. Write each of the following in the form of a radical b, where b is a positive real number. Let's go now for the first example, 3 radical 2. Can you write radical 32 in form of even power? No. But we know that 32 is a product of two numbers. So we will try to say that 32 is the product of 8 times 4. Yes, it is a product of two numbers, and one of them is of even power. But still 8 can be written in the form of even power in a way or another. So can you find another combination of product of two numbers in which we get 32 and we still have an even bigger power? Yes, it's 16 times 2. So it's better to write 3 radical 32 in form of 4 squared times 2. Or we can write 3 radical 2 power 4 times 2 to finally have divide the power by the index to get 3 times 2 squared radical 2 and calculate the product of the coefficients to get 12 radical 2. Now which is in form of a radical b. Radical 5000. Try to write it in the form of power of 10. Now it's 5 times 10 to the power 3. 3 is not an even power. We'll try to write it in the form of 5 times 10 to the power 2 times 10. Finally, we will get 10 square root of 10 times 5, 50. Minus 2 radical 36. It's minus 2. What number I can square it to get 36? It's 6 squared, which is equal minus 2 times 6, which is equal minus 12. But wait, this is not in the form of a radical b. Okay, we can always write minus 12 radical 1. Now it's in the form of a radical b. This is a equals minus 12, and b equals 1. Now, again, since it's in a decimal form, try to write it in the form of power of 10. Square root of 7 times 1, 2, 3, 4 decimal positions, 10 power minus 4. Even power again, divide power by index to get 10 power minus 2 square root of 7. Another set of reminders. Now we can always write the product of two radicands, radicand A times radical B, as of the form radical AB. And the ratio of radical A to radical B can always be written in the form of radical A over B, where A is a positive real number and B is a strictly positive real number, that is to say B is not 0. Now, to calculate A radical B times C radical D, we multiply coefficient by coefficient and radicand by radicand. That is to say, we multiply coefficient A by coefficient C and the radicand B by radicand D. Now, if A is a number which is greater than or equal to 0, then we can write B radical A plus C radical A as the sum of the coefficients B and C radical A. This is adding or subtracting radicals. A set of applications on multiplication. Write in form of A radical F, where F is a positive real number. A, B, and C. Okay, now let's start with the first expression. Now, how to multiply these? To multiply this, we know that we distribute 2 radical 3 over the parentheses here. So we multiply first by first, then first by second. But how do you multiply first by first? We have said that before. We multiply coefficient by coefficient and radicand by radicand to get 10 radical 21. 5 times 2 is 10, 3 times 7 equals 21, minus, now, first by second, coefficient by coefficient, 2 times minus 1 is minus 2, radical 3 times radical 3 is radical 3 squared. Now, since this radicand has an even power, we can get it outside to get 10 radical 21 minus 2 times 3. Finally, we get 10 radical 21 minus 6. This is your final answer. Now, the second one, B. Take a good look at it and you notice something here. Yes, it's a product of conjugates. A minus B multiplied by A minus B. A plus B. Now, product of conjugates in expanded form is equal to A squared minus B squared. So here we can write 3 radical 5 all squared minus 2 radical 3 all squared. Now distribute the power over the first parenthesis to get 9, and radical 5 squared is 5 minus square for the 2, we get 2 squared, which is 4, times radical 3 squared is 3, so 45 minus 12, thus B would be equal 33. Now for the last question. Now notice that this is square of sum. It's A squared plus double AB plus B squared. So here we will apply the formula to get 2 radical 3 all squared plus the double of A, which is 2 radical 3, times the B, which is 5 radical 2, plus 5 radical 2 all squared. Now distribute the squared, you get 4 times radical 3 squared is 3, plus, now pay attention here, how do you multiply it? Multiply again coefficient by coefficient. 2 times 5 is 10, 10 multiplied by the double there, it's 20, radical, coefficient by coefficient is done. Now you multiply radicand by radicand, 3 by 2 is 6, plus distribute again the power to get 5 squared is 25, times radical 2 squared, it's 2. Now you'll get 12 out of here, plus 20 radical 6, plus 50. Add similar monomials, to get C equals 62 plus 20 radical 6. Now, another set of applications on addition and subtraction. Write in form of E radical f, where f is a positive real number. A, B, C. Now A. Remember, in order to add radicals, they should have same radicand. Else we should do something. Okay, here we have same radicand. So we just add the coefficients. 13 minus 5, we get 8 radical 2. As simple as this. Again, in B we have same radicands, so we can add coefficients directly to get 28 radical 3. Now in the third example, we notice that we don't have the same radicand, so we have to try to write one of the radicands in the form of the second one. Now obviously we have to write 20 in terms of 5. Now what is 20? Yes, it's 2 times 10. But still, there is no even power. So can you write it in a better form? Yes, it's 4 times 5. Or you can write 2 squared times 5. Now, to get minus a 3 radical 5 plus 11 radical 2 squared times 5. Now, equal minus 3 radical 5 plus take 2 squared out to get 11 times 2 radical 5. Now minus 3 radical 5 plus 22 radical 5. Add. Now we have same radicand. All you have to do is add coefficients. So minus 3 plus 22, it's 19 radical 5. This is C. Okay, so now remember, if you need to add or subtract radicals, you should have same radicands. Else you have to work out something. Okay. Our last set of general applications, write in simplest form possible, A, C, and E. Let's start with A. Notice that this part of A is a square or difference, so its expanded form is A squared minus the double of A multiplied by B plus the second term squared plus the rest. Now work out the square to get 9 minus, pay attention here, it's a little bit tricky. Now multiply coefficient by coefficient to get 3 times 2 is 6. Now double the 6 is 12. Now where is the radicand? The other radicand, yes, there is. It's radical 1. So multiply radical 1 by radical 2, you'll get radical 2 plus distribute the square here, you'll get 4 times radical 2 squared is 2, it's 2, which is plus 12 radical 2. Notice here we have opposite terms, so they add up to 0. Add 9 plus 4 plus 2 times 2, you'll get 17. This is your final answer. Now, what about this? Now to multiply this to get the answer. Now to calculate C, we distribute first by first, first by second, second by first, second by second. Let's start first by first. Again, coefficient by coefficient, radicand by radicand. Coefficient by coefficient is 1. Radicand by radicand, you get a radical 15. Now first by second, again, coefficient by coefficient plus 2 square root of 5 times 6, nothing here to be of an even power, so it's radical 30. Now second by first, coefficient by coefficient, 2 times 1 is 2, it's minus 2. Radicand 1 times 3, it's radical 3. Second by second, minus, again 2 times 2 is 4. Radical 1 times radical 6 is radical 6. Now, can we add any of these radicands? No, they can't be added. They are of different radicands, and none of them can be written in form of another. So this is your final answer. Now for E, wow, this is the most difficult one. No, it's the easiest one, believe me. It's only need from you a little patience. To start working out such an expression, always start from the last. Now, you'll have square root of radical 6 minus radical 21 plus radical 13 plus radical 7 plus, what's the radical of 4? It's 2. So you'll have to equals square root of 6 minus square root of 21 plus radical 13 plus radical 7 plus 2. They are under the same radical, so we can add them. 7 plus 2 is 9. 9 is 3 squared. So this would be equal now. Let's write it here. Equals radical 6 minus radical 21 plus radical 13 plus 3 squared is 3, which is equal square root of 6 minus radical 21 plus radical 16 under the same radical, so it's 4 squared. Hence we'll get radical 6 minus radical 21 plus 4. Add these together, you'll get radical 6 minus radical 25, which is 5. Now which is equal radical 6 minus 5, it's radical 1. Imagine all of this is nothing but 1. Now your assignment is solve the following questions.